Hello and welcome to CS 112's Lesson 15.2 for the University of Idaho Dual Credit Program. Today we're going to be doing Lesson 15.2. We're going to be doing some simple shapes. So go ahead and run this processing code. Take a little bit of time, write it out, know how it kind of works. And once you have accomplished that, and definitely feel free to pause this until you get that done, what you're going to be doing is you need to look at this line right here and try to determine what does this mean, and even more specifically, what does this do? Check out the reference section of your uh, up here at help and click on reference and try and figure out what that percent actually does. Like I said, definitely take a minute and try and figure that out. All right, hopefully you paused and are getting back to us right now. In this warm-up, what it should have done is it should have drawn a whole bunch of circles going across the screen, and as it's kind of going across the screen as going down, it actually changes color, and kind of a cool little thing. And specifically, the reason that we did this is a couple things that you should note is we used HSB, hue, saturation, brightness. We used that and kind of in order to make this effect. And we used a couple of for loops as well, which definitely helped with that. And what we saw is right here, this eColor percent 360, is that's the reason that the colors kind of change kind of as the circles are drawn. This is why it changes. And so each time that it's kind of reset, it goes back. And so what actually is happening here is this. This right here is the modulus function. That modulus function is something that we've used before, and what it does is it gives us what the remainder is. What's the remainder of this specific thing? Okay. All right, go ahead and delete that. In 12.4, we were able to create some custom shapes on our own. In this one, we're going to create a simple custom design, but we're gonna make it so that it's scalable, and that's kind of going to be the really big thing. Is going to make it scalable. So as always, we're going to start with some void setup and some void draw. Oops. Void setup, void draw. We're going to fill some information in on there. Let's first start with our setup. Let's give it a size. Let's say size of 300, 300. And let's make a rocket, because rockets are really cool. And what we're going to do is let's go ahead and draw let's make the background white every time. That way, if it starts moving, it can kind of refresh. And then we're actually going to do something a little bit different here. We're going to actually draw rocket. Now, processing in and of itself does not know what we mean by draw rocket. You and I might know what I mean when I say draw rocket, but processing itself does not. And so what we need to do is we're creating a new program. We're creating a new function, not a program, sorry. A new function called draw rocket. So do we expect draw rocket to return anything, like value-wise into the program? No, we expect it to draw a rocket. So what we're going to say is we're going to say void draw rocket. Oops, not with a semicolon, the bracket. And let's close the bracket. So let's go ahead and let's draw to start off with, let's draw the center. So let's draw a rectangle, and let's keep it in the center. So we're going to do width divided by 2, height divided by 2, 30, 90, and if I click that button, oh, it's not quite center. The reason why that it's not center is the fact that whenever we start drawing with a rectangle, it draws from the upper left corner. So, alright, let's go ahead and try and fix that. And let's at the same time try and give it some like color and stuff like that. Make it a little more interesting, right? So, let's change our rect mode. Now, it's kind of important, and we've talked about this before, that we want this rect mode to be as close to kind of where we use it as possible so that we don't mess everything else up. As I said, let's make some color here. So let's make the stroke 255 so it's white. Let's make the fill, let's make it a blue rocket because blue is fun. 255. And if I push play, all right, I got a blue rectangle. We're getting there. All right. So kind of starting off, and sometimes it's nice to do this ahead of time. Sometimes it's nice to do it after the fact. But what we're working on today is to make it so that it's kind of scalable and things can be moved easily. And while yes, being able to say specifically the width and the height is nice, it would be actually a little bit more convenient if we could make it so that it was a part of the actual program. So in this, let's change some stuff up. So right here, let's make a couple floats. And we're going to declare what the floats are as we're going, so we're going to do them all separately. We're going to do this one be the width divided by 2. And then we're going to make the y be the height divided by 2. And you could probably start seeing on this one, oh, actually it's going to be a lot easier, especially if we're going to write a whole bunch of rectangles, to use x and y. And we're actually going to use this a lot, and so it's kind of important to be able to do that. Now the next thing that we're going to use is something that you probably didn't think about. And what that is whenever we're dealing with this rectangle, we have 90 and 30. And I kind of want to keep these proportions the same. It kind of gives it that more elongated look of a rocket. So what I say is all right, let's make another float. We're going to call it rocket size. And we're going to set it equal to 90. Why? Because that's whenever I think of size of the rocket, I don't really think the width, I think of the height. And so I'm going to change this to be rocket size. And to keep this idea of being able to scale everything, I'm also going to change this to be rocket. It was 30, remember. So we need to have rocket size divided by 3. Now, if we did everything right, it should look exactly the same. Hey, it does. Cool. All right. Now, the next thing that we're going to add into this is something that we're going to call the offset. And what the offset is it's going to make it so that we can be off the center. We already did, or like in the kind of the left-right direction. We already did that with, kind of height-wise. Height-wise, it's pretty easy to do. But whenever we're trying to kind of like be like half the width that we already are, it's a little bit more. So what we're going to do is, because we're using rocket size already, we're going to make a float called offset. And what we're going to do is we're going to set that equal to be the rocket size divided by 6. And it is important to have this offset happen after you set this float. The reason why is because we're using rocket size here. If there was something from before, it might mess with stuff just a little bit. Alright. And so far we haven't used this, and so far we don't need to use it. But that's because so far all we're at is the body. And so what we're going to be doing next is the cone. So we're going to make a fill of 210, just so we have a little different color, and a triangle. And that triangle, we're going to kind of give some aspects to. So what we're going to do is, if you think of the cone's at the top of it, we're going to go to the left side of the rocket, to the right side of the rocket, and we're going to be above the rocket. And so we kind of have to give those points whenever we're talking a triangle. Triangle expects 3 points. So we're going to give it that left side, that right side, and that top. So the left side is going to be easy enough to kind of imagine. So that's going to be dealing with our x's, is going to be minus our offset. And what this will do, this will actually kind of bridge that gap. I'm going to skip the y for right now. We'll get back to it. To kind of going left to right almost with our triangles as we have on the left, then in the center, then we're going to have on the right. And in the center, we're just going to be at x. All right, let's go ahead and skip a y. And then we're going to do x plus the offset. And now we're off to the right. And we still have to give another y. We haven't gotten to those yet. But we're going to get to those right now. Now, whenever we're doing the x and y changes, the y's are going to be above it. And so it's really easy to think on your first instinct of like a plus. But remember, with processing, it's actually in the other direction. So we're actually going to go in the other way. And so we're going to go y minus, and y minus what? Well, we're already starting in the center whenever we're talking with y. So we only need to go half the rocket size. So we go y minus the rocket size divided by 2. And we're actually going to do that with this one over here too. We're going to do y minus the rocket size divided by 2. Now we have one final thing, and what that is going to be is we need to kind of have it go up a little bit. If we did the same thing, it's going to be a straight across line. It's going to be pretty boring. So we need to go up. And so let's just do y minus the rocket size. And that should kind of work. Let's have a look. Hey, all right, we got ourselves a little nose cone. All right. So it's pretty scalable right there. I mean, everything, there's like no, like, kind of hard numbers anywhere in here except for like what the colors are. Now let's add something else. Let's add some fins. I call them fins. Some people call them boosters because they're crazy. So let's do some fins. And what these fins are is these are going to be triangles on the side of the screen, or of the rocket. So let me pull this up again for you, just so you can see. So so they're going to be on this they're going to be to the left side, and they're going to be to the right side of they're going to be left and the right side of these rockets. So, and we're going to make them triangles. Why? Because that's just easy to do. Oops, not plural, triangle. And again, we expect 3 sets of ordered pairs. So, kind of thinking of it, I kind of want to start against the rocket and make sure I'm against the rocket. So I'm going to say x minus the offset, and that's going to have it against that left side. I'm not going to deal with the y's yet. And then this next one, I kind of want to say, all right, now I'm going to go out to that far extreme, that far distance. So I'm going to go x minus the 2 times the offset. Again, I'm going to kind of skip the y's for right now until I get to them, and then I'm going to come back to the x, and I'm going to say, okay, now I want this is going to be that top one. We're going to go x minus the offset again. That way we're against the rocket again, and we're going to need another y in there. So the next thing that we're going to do is we're going to put in the y's, and we kind of got to think about, all right, where are we located at? Now we're down at the bottom of it, and remember, unlike the cone, we're actually going in the opposite direction. So what we're going to do is we're going to do y plus, and we want to be at the very bottom. So we're going to use, kind of like we did above, rocket size divided by 2. This set, we also want to be in the same place. So we want to be y plus rocket size divided by 2. Now this last one's a little bit different. We want it to be higher up, so we don't want it right there, but we don't really want it in the middle. It's not going to quite look realistic. So what we're going to say is we're going to say y plus the offset, and I guess realistic isn't the right term. It's not going to look as pretty. And so if I run this, and I just realized you didn't see any of that stuff that I did. So take a minute and pause and see this. Sorry about that. So now what we have is this triangle. And so we have this triangle, it's on the left hand side, and it looks pretty good. Now we need to draw a right one. Well, how do we draw a right one? Well, the way that we're going to draw the right one is we're simply going to copy this and reuse it. And instead of being on the left side, which is what these x minuses did, we're going to be on the right side. So we just change these minuses to pluses. And if we run that, we have a rocket. All right, so go ahead, and what we're going to do is we're going to try changing some things. We're going to change some values and make sure that everything actually is still scaling. So what I'm going to do is I'm going to change this to, instead of being width divided by 2, I'm going to say 100, which I look at this and it should be a little bit to the left of where it started. So if I hit run, and I look at it, yep, it's a little bit to the left of center. All right, it followed it there. Does it do it in the y direction? All right, let's change our y. Let's change our y to be 200. It moved it down. Awesome. Now the last thing that we're going to do is we're going to try and make it bigger. So let's change this to 120. It made it bigger. Awesome. So that means that it was definitely scaling right. So what we're going to be doing now is our assignment. Your assignment is this. Use rectangles, ellipses, or triangles to create your own shape, and be creative. It should be drawn with all points relative to the center of the shape, just like we did with that rocket, where we can change just a few variables somewhere else, and it's going to change everything. Have 3 to 5 features for that single object. The rocket, for example, had a body. There's 1. A cone. There's 2. And 2 boosters. That makes 4. There's 4 things on that rocket. The shape should be drawn in a function separate from draw. So it should be in a function that's called in the draw function. Test your code. Make sure it works. Make sure it changes both location and size and doesn't get all kind of weird. Check for those kind of, like I call them, hard numbers. Make sure you're not putting in like 20. Whenever you're first testing, that's fine. But whenever you're finishing, make sure that everything kind of moves with it. Be sure to comment on all sections of your code. Submit your assignment as a zip folder to wherever your teacher kind of wants it. And as always, happy coding.